So, in fact, once we have the k and the beta, they are interchangeable, because in many classical textbooks you see this beta and k. Okay? And when we are going to cover the case, when we have some conductivity in the system, we are going to see that the propagation factor, we are going to write it alpha plus beta, where one part is real, the other part is complex. So that's why often you can assume that if I write sometimes in the class beta, at least during these topics, you might know that R1 means this, okay, which means soprattutto durata, present. Do should figure durata. Present. So in the previous class, actually, what is a trick that can be conducted is that if we are given the H, from H we can find the electric field, and from the electric field we can find magnetic field again. Okay, so we can do this one. These are also nice examples to work with, because if we do this one twice, in the end we will have to equal the H that we find with the initial H that we were given, and this will also, this is somehow, you know, when you have some unknown variables. Exactly. So when you have some unknown variables, you add another equation to find this unknown, and then this can help for that aspect. But then try to identify some similar example. Okay, yeah, actually, this example that you just mentioned, actually, we don't even need to pick up numbers. Let's give one. Let's assume that we give the H initially. So H, the magnetic field intensity, this can be equal to, let's give this one AX. Then let's give some value here, 2. This is the amplitude, and this would be e to the power minus j k. This is along the x, let this one propagate along the z, kz. And k, now k, it is, so let's write it like this, k, it's a function of the wavelength. Wavelength is a function of the frequency, right? So this is a function of frequency. And k, it is also directly linked with omega, because now this is just linked. Okay, these are not equal. Maybe so. This is also a function of frequency. So these are interchangeably depending on each other. And regarding the question that you asked to me, what we can do is that once we're given the H, we can try to find the E. But how do we find the E? Let's have a look at the curl equation, but it is good if you check this one also in your cheat sheet for the formula. So this curl will be equal to J, permittivity, omega, E. I think it's E, right? So this is E. And then let's try to, amplitude is simple. Then this, from here, we can say that E, it is equal to 1 over J permittivity omega curl of H. On the other side, we have the curl of E is equal to minus j omega mu. What is this? H, right? Which means that the H is equal to minus 1 over j omega mu, the curl of E. Okay, so let's start from here. Then the curl of H is equal to, let's have here ax, ay, az, derivative with respect to x, derivative with respect to y, with respect to z. This is 2 e to the power minus jkz, 0, 0. And this is equal to, let's say, the coordinate along the ax is equal to 0. The coordinate along the ay apparently is different from 0. So let's write this one, ay times 0 minus, so let's write this one, 0 minus the derivative of this expression with respect to z. So this will be minus, so here we have, what is the derivative with respect to z? We'll get a minus jk, right? So minus jk times 2, it is always there, times e to the power minus jkz, e to the power minus jkz. And then the component along the az, it is equal to 0 because the derivative of this one with respect to y is 0, and derivative of a constant value with respect to x will be again 0. So then this is equal, the curl of h, apparently, this is equal to plus, so this is ay jk 2 e to the power minus e jkz, and this whole thing, the curl of, let's substitute this one here. This will be equal to ay, yes, this is ay jk 2 e to the power minus jkz divided by what? J permittivity omega. So j is cancelled out, and this is what we obtained. So let's have a look. This is ay. 2 is the amplitude, but let's give this one k. Permittivity omega 2 e to the power jkz. Now that we have this e, we can calculate the curl of e. To find the curl of e, this will be equal to ax, ay, and az. Here we have a derivative with respect to x, derivative with respect to y, and with respect to z. And we see that e, or what should we do here? Wait a second. So we found e right here. So this is equal to, this is 0. It has a non-zero component along the ay. So this is 2k over permittivity omega, 2k over permittivity times omega, times e to the power minus jkz, e to the power minus jkz. This is 0. So now, what should be the direction of this curl of e? Ce dreptime тут chem? Should be x, right? Because we should find from here, we should find the h. And by the way, also, we had h, it was along the ax, so the curl of this one, for sure, it's going to be perpendicular to this. It should also be perpendicular to z. So it should be ay, that's why I got ay. And also here, we have the e, it is pointing along the ay, so the curl of this one should definitely be perpendicular to this. And by the way, we know that from h, we found this, it's over there, and from here we have to find this. So this result here, it will have the non-zero term, only the ax. And this ax, this will be equal to, we have the derivative of 0 with respect to y over dy minus the derivative of this term with respect to z. So the derivative of this term with respect to z, this will be minus 2k over permittivity times omega times minus jk e to the power minus jkz. So this is the curl, okay? And this whole expression, this can also be written, this is 0. So this is going to be ax times minus j, with a minus it becomes plus. So this is going to be ax times j times 2k squared, right? Divided by this expression and omega. Anything we're missing? E to the power minus jkz. Okay, so we found what is the curl of E. Now that we know the curl of E, let's substitute this one in here. So if we are trying to substitute this here, this will be equal. Wait a second, where did we get this negative sign? Yes, it should be there because of this. So this is no, minus 1 over j omega mu. And let's substitute now the curl. The curl, we have here j2k squared divided by permittivity times omega times ax. We should write this at some point, times e to the power minus jkz, e to the power minus jkz. So we got a negative sign, and this whole negative sign, this should be, so this is h, right? We got all of these terms. Now all of these, this should be equal to whatever we had initially, right? So we derived them twice, and finally we should get the same thing, because and this would be equal to 2 e to the power minus jkz times ax. So let's have a look now at this expression. And we notice that we can, this term is on both sides, and this 2 is also here. So we can say that all the terms that are in here, also the j's, they can cancel out. We can say that minus 1 times, so minus k squared divided by omega squared permittivity. Anything else? That's it, right? This would be equal to 1. But we have a minus sign. Is minus sign okay? What do you think? Or did we do some mistake on the way?
Додали треба позитивити, але омега чекає, що далі probability.
Okay. But one thing which I'm not sure for the moment is that whether this minus sign is okay. Now I believe. Let's have a look later at the sign. But somehow we indirectly, just because of the Maxwell's equations, we find the dependency between the k omega and the speed of light, because we know actually that the speed of light c, it is equal to 1 over mu 0 epsilon 0, right? And this is equal to 3 times 10 to the power 8. And at the same time, let's see, this is so this u squared, it is actually always equal to this, even when this can be written in this way. This is mu r, mu 0, epsilon r, epsilon 0. So this would be for any material. That's true. So this would be the speed in any material, if this is a material is magnetic or non-magnetic, or whether the epsilon r is different from 1 or not. Në vakum, kjo mu r është barabartë me 1. Edhe në ajer, kjo epsilon r është 1. Por në material tjetër kjo do ndryshojë. Because the permittivity always is written like this. Permittivity is equal to ER E0, and the permeability is equal to mu r mu 0. Okay, but now we know that we are in vacuum. Mu r and epsilon r, they are 1. So this is going to be c squared. So then, when we look at this expression, we can say that k squared, it is equal to omega squared times this. Okay, so this is the first thing that we get from here. After this, we can also say that k squared, it is equal to omega squared divided by c squared. So it looks like we kind of find out that k, it is omega divided by c. Okay, so, and k omega divided by c, c is always equal, so actually we keep writing the same things again and again, but I want you to kind of memorize this. At least we're going to take waves next semester, and you might see this one again a few times. So this question that you asked actually is something in this line. Okay, this is how, because when we take the derivative with respect to time twice, we get j omega, right? And then 2 times we get omega squared. But then each time, in one of the flux derivatives, we get the mu, in the other one we get the permittivity. So all of these terms come into play. And since we have also 2 derivatives with respect to k, we get this k squared, okay? So where did we get this case? 1k is when we took this derivative with respect to z, right? And we got this. And this k, then it is found duke gjithë në dyshin. Ku ke dyshin ke edhe këtë tani. Kur morëm derivatin tjetër pas këtu, zbrit edhe një këtë tjetër, këtë 2k apo 2k katror, e kështu me radhë. Njëkohësisht funksionin që ashtu dhe këto omega katrore që vinë nga derivatet me kohën, kemi edhe këto që në dalin të mjuja me permittivitetin, permeability and permittivity. Where do they come from? They come from here. So this is the permittivity, and this is the permeability. Because the derivative with respect to time, there are derivatives of the fluxes, right? Kush janë flukset bëja dhe doja në flukset. Kush e dhe hëja në intensitetet. Pra, edhe kur bëjmë boundary value problems, e dhe hëja konservohet vetëm e komponenti që është tangjent me zonën ndarëse që ndan dy ambiente të parën dhe dytin, kurse flukset konservohen bëja dhe doja, edhe po të jemi impulsi vektor, ato konservohen, që do thotë që se kalojmë nga ajri në xham, doja nëse ka një vlerë 4, komponenti pingull, do të jetë 4 edhe kur futet në xham, që është ambient i ri, që është ndryshe nga vakumi. Kurse, pra, është diçka që kemi shprehur më përpara, që fluksi është një madhësi më fundamentale se intensiteti, sepse edhe si madhësi është më lehtë që të konservohet. A ka ndonjë gjë të paqartë në një pyetje? Tani shikoni gjërat e paqarta, shikoni çfarë keni gjëra që si kuptoni që të pyesni sepse javën që vjen do të kemi kryesisht përsëritje.